Let's start with our first question. Determine the frequency and draw the output waveform of the circuit mentioned below. This is 555 timer and this is type of A-stable 555 timer. First, before solving our question, we have to know about the 555 timer. 555 timer is basically used to produce a timing circuit used to produce stable and accurate delay or oscillation. It is also used for multi-oscillator circuits to produce the waveform like square wave generators. This is two type of 555 timer. First one is monostable and second one is stable multivibrator. First of all, we know about the different 8 pins of 555 timer. This is our VCC where we apply VCC like 5 volt to start our 555 timer. 4 point is reset point from where we can reset our 555 timer to 0. And third one is our output point from where output is taken out. And fifth one is ground and control. Control is basically used to control our 555 timer for timing of oscillation of 555 timer, and ground used to make circuit stable. Next, trigger and threshold. Trigger is used to apply the input signal to change the state of 555 timer, and threshold is the voltage set to start working capacitor in proper way. Next, discharge. Discharge is a point where extra voltage is passed through the capacitor when unnecessary voltage is occur in 555 timer. Let's start with monostable multivibrator. First of all, when input signal is applied T high, let's take it T1, then capacitor will start charging through RA and RB. This RA capacitor charge through this RA and RB, and voltage change from capacitor from VCC by 3 to VCC by 3. Because of in 555 timer there are 3 resistors are used, and voltage are at 2 different points are VCC by 3 and 2 VCC using voltage divider rule. And time constant for the charging of capacitor is TC is equal to RA plus RB into C. First of all, you use transient analysis of capacitor. Capacitor will charge as a VC is equal to VF minus VI into e power minus tau upon T upon tau. Initially, our capacitor is charged with VCC by 3 and finally charged with VCC. And our input voltage at the 555 timer is 2 VCC by 3. After solving the equation and applying the logarithm both sides, then we calculate the T1 time, that is tau c ln2, and it is equal to 0.693 tau c. And this equation, our T1 is applied and input signal is high, and capacitor will start charge through RA plus RB. So overall T high is equal to 0.693 into RA plus RB. Now comes to the solution. When T is high, then capacitor will charge with 0.693 RA plus RB into C or 0.7. Let us take 0.7. Then our RA is equal to 7.5 kilo ohm and RB is equal to 7.5 kilo ohm and capacitor is 0.1 microfarad. Okay, then put the value of RA, RB and RC and we'll get the T high is equal to 1.05 millisecond. For T low, capacitor is this is a graph of capacitor charging from VCC by 3 VCC by 3 to 2 VCC by 3, and capacitor will charge till the voltage is high, and when our pulse is low or pulse is off, then capacitor will start discharging, and discharging T low will be only through the our circuit RBC. This will be way through which our capacitor is discharged, and the discharging of capacitor will be 0.7. Same, only tau is our change, and this is tau will RBC, and T low is equal to 0.7 RBC, and put the value of RB and C, we will get the T low, and this is equal to 0.5 to 525 millisecond. Overall time period of this waveform is equal to T is equal to T high plus T low is equal to 1.05 plus 0.525, and overall time interval is 1.575 millisecond. And we will then calculate the frequency by applying f is equal to 1 by t and get the frequency is equal to approximately is equal to 635 hertz. Now comes to the waveform. When capacitor will charge, it goes up to the 3.3 maximum voltage. This is 2 by 3 VCC, and after discharging capacitor is goes to minimum value of 1.67. This is 1 by 3 VCC, and our time interval is 1.57. That's we all already calculated, and T high is equal to 1.05 and T low is equal to 0.0525. This is our input waveform, and this is our output waveform through which capacitor will charge and discharge. This is the overall solution. Next, come to the next question. This is next question. Determine the period of output waveform for the circuit below when triggered by the negative pulse. Here we apply the negative triggering, and this is our monostable 555 timer. In monostable 555 timer, only RA is present, and tau C will be changed, or for T input only time constant will be changed to 0.693. Here tau constant will be changed, and we will calculate like this. Let's come to the derivation. For monostable multivibrator, our T high will be same, but our initial voltage is equal to 0, and our final value is equal to VCC by, and our final value is only VCC. So overall calculation will come that T is equal to tau C ln 3, and ln 3 is equal to 1.1. So 1.1 into RAC, and put the value of RA and resistor and capacitor, and we will get the T high is equal to 0.825 millisecond, and we will get the output time period of the output waveform after applying negative triggering. That's all, and these are the formula that are we use in monostable and astable 555 timer. For T high is equal to 0.7 RA plus RB into C, and T low for 0.7 RBC, and total time period is equal to T high plus T low, and frequency we will apply formula f is equal to 1 by t and get overall the value of, after applying these values, we get frequency is equal to 1.4 upon RA plus 2 RB into C. This direct formula we can use to get the value of frequency. Thank you.